In this assessment, we're asked to give a ketone and a Grignard reagent that will react to make this tertiary alcohol. Recall that ketones with Grignards or organolithiums will always give tertiary alcohols as products. The question goes on to ask, are there more than one way? In fact, there are. There are three. I'm going to give you bonus footage. We're going to get to see all three ways that we can do this. Now, it turns out that whichever way we start with is going to proceed with the same last step, and that's going to be to protonate this alkoxide. So regardless of what bond we make, we're going to finish this reaction with an acid quench. And so what that then allows us to do is to look at the individual bonds that we would need to make in order to generate this product. Let's start with the bond we've labeled as A, and we'll do this in orange. In order for this to happen, we're going to make this new carbon-carbon bond with our 5-membered ring as our nucleophile. And so it will be the Grignard reagent. If it's the Grignard reagent, then what remains from here to here has to be the ketone. And so we could number the carbons if we wanted. It might make our thing a little bit messy before this is over. But if we number our carbons, we know that we're going to have 5 carbons. 1, 2, 3, 4, 5. Carbon 2 should have the ketone. And so this Grignard reagent with this ketone should give this, which upon acid quench gives us our product. What if we wanted to make bond B? Well, now we're going to be adding a methyl Grignard, and just to mix it up, we'll write the methyl Grignard over the arrow in this way. The rest will be the ketone. So we'll have the 5-membered ring, and then we go up to carbon 2, down to carbon 3, up to 4. We'll put 5 in there, throw the numbers on, just to be clear. This carbon that's the methyl that's added is in fact carbon 1, and so we need a ketone at carbon 2. That Grignard reagent would give this alkoxide, which on acid quench would also give the product. Now I'm going to switch to the yellow color. It's not that different than green, so it might blend. I am using a different marker. It's yellow. Let's make bond C, which we've denoted with this squiggly line here. Now 3, 4, and 5 are going to be the Grignard. So the Grignard reagent is at carbon 3. This is carbon 4. This is carbon 5. Our ketone, notice our ketone is always going to be at carbon 2, and each of these is going to be at carbon 2. In this case, the ketone will look like this. So we'd have this being carbon 2, this is carbon 1, and then, of course, the 5-membered ring. This ketone with this Grignard would also give this, which upon acid quench gets that. I apologize for the long video, but I felt like you deserved all 3 answers to this question, since the one you generate maybe wasn't the one we did first. Which one's better? None, right? All of them are fine. If we're actually in the lab doing this reaction, it's going to be based on the availability of reagents. So if this Grignard reagent can be purchased, then we're probably going to use that one. If this Grignard reagent, we know methyl magnesium bromide is available, but we would have probably had to synthesize this ketone. The point is, for the purposes of this assessment, any of the 3 work. In the actual lab, it's going to depend on other factors. Even more bonus coverage. Who knew that you would get advice for research lab in this assessment video? Good luck.